Hello students, welcome to NCERT Zone. In this video, we'll be discussing all the questions and answers of the fourth chapter of class 9th science, that is structure of the atom. Let's start. Our first question is, what are canal rays, right? The answer is canal rays are positively charged radiations. These rays consist of positively charged particles known as protons. They were discovered by Goldstein in 1886. Second question is, if one atom contains one electron and one proton, will it carry any charge or not? I'm repeating the question. If an atom contains one electron and one proton, will it carry any charge or not? The answer is an electron is a negatively charged particle, as we know, whereas a proton is a positively charged particle. The magnitude of their charges is equal. Therefore, an atom containing one electron and one proton will not carry any charge. Thus, it will be a neutral atom. Okay, let's move on to another question. Next question is, on the basis of Thomson's model of an atom, explain how the atom is neutral as a whole. On the basis of Thomson's model of an atom, explain how the atom is neutral as a whole. Answer is, according to Thomson's model of atom, an atom consists of both negatively and positively charged particles. The negatively charged particles are embedded in the positively charged sphere. These negative and positive charges are equal in magnitude. Thus, by counterbalancing each other's effect, they make an atom neutral. Okay. Second question is, on the basis of Rutherford's model of an atom, which subatomic particle is present in the nucleus of an atom? The answer is, on the basis of Rutherford's model of an atom, protons are present in the nucleus of an atom. Next question is, draw a sketch of Bohr's model of an atom. This is the structure of Bohr's atomic model, right? This is nucleus in the center, and these all spheres are shells. Next question is, what do you think would be the observation if the alpha particle scattering experiment is carried out using a foil of a metal other than gold, right? If the alpha scattering experiment is carried out using a foil of a metal rather than the gold, there would be no change in the observation. In the alpha scattering experiment, a gold foil was taken because gold is malleable and a thin foil of gold can be easily made. It is difficult to make such foils from other metals. Next question is, name the three subatomic particles of an atom. The three subatomic particles of an atom are protons, electrons, and neutrons. Next question is, helium atom has an atomic mass of 4 units and 2 protons in its nucleus. How many neutrons does it have? I'm repeating the question. Helium atoms has an atomic mass of 4 units and 2 protons in its nucleus. How many neutrons does it have? The answer is, helium atoms has 2 neutrons. The mass of an atom is the sum of the masses of the protons, as we know, and neutrons present in its nucleus. Since helium atom has 2 protons, mass contributed by the 2 protons is equal to 2 into 1, 2 unit. Then the remaining mass 4 minus 2 unit, that is 2 unit, is contributed by neutrons. So the number of neutrons helium have is 2. Let's move on to another question. Write the distribution of electrons in carbon and sodium atoms. The total number of electrons in a carbon atom is 6. The distribution of electron in carbon atom is given by first orbit or K shell is equal to 2 electrons by the formula of 2n square. second orbit or else shell is equal to 4 electrons, or we can write the distribution of electrons in a carbon atom is as 2 and 4. The total number of electron in a sodium atom is 11. The distribution of electrons in sodium atom is given by first orbit or K shell. The number of electrons will be 2. In second orbit or L shell, the number of electrons will be 8, and in third orbit or M shell, remaining electrons will be distributed in that last shell. Okay, so the number of electrons in third orbit or M shell will be 1. Or we can write distribution of electron in a sodium atom is 2, 8 and 1. So how this is happening, how we can distribute the number of electrons in all the shells. So in the lecture of this chapter, that is structure of atom, we have discussed that the number of electrons distributed in all the shells is based on the formula 2n square, right? So in first shell or in K shell, the number of electrons will be 2, in second 8, and in third 18, and so on. Okay, let's move on to another question. If K and L shell of an atom are full, then what would be the total number of electrons in the atom? Answer is, the maximum number of electrons that can occupy K and L shell of an atom is 2 and 8, as we know. Therefore, if K and L shell of an atom are full, then the total number of electrons in the atom would be 2 plus 8 is equal to 10 electrons. Okay. Our next question is, how will you find the valency of chlorine, sulfur and magnesium? The answer is, if the number of electrons in the outermost shell of the atom of an element is less than or equal to 4, then the valency of the element is equal to the number of electrons in the outermost shell. On the other hand, if the number of electrons in the outermost shell of the atoms of element is greater than 4, then the valency of the element is determined by the subtracting the number of electrons in the outermost shell from 8, right? The distribution of electron in chlorine, sulfur and magnesium atoms are 2, 8, 7 and 2, 8, 6 and 2, 8, 2. That is, in chlorine the number of electrons in last shell is equal to 7, in sulfur in third shell the number of electrons is 2, and in magnesium the number of electrons in last shell is 2 respectively. Therefore, the number of electrons in the outermost shell of chlorine, sulfur and magnesium atoms are 7, 6 and 2 respectively. Thus, valency of chlorine is equal to 8 minus 7, 1. The valency of sulfur 8 minus 6, 2, and the valency of magnesium is 2. Okay. Let's move on to another question. If number of electrons in an atom is 8 and the number of protons is also 8, then what is atomic number of the atom and what is the charge on the atom? So the first answer is, the atomic number is equal to number of protons. Therefore, the atomic number of atom is 8. As we know that the atomic number of any the atomic number is always equal to protons. So the number of protons is 8, then atomic number will be 8. And the answer of second question is, what is the charge of the atom? Since the number of both electrons and protons is equal, therefore the charge on the atom is 0, right? So when there will be as much proton as electrons are, so the charge on the atoms will be 0. Second question is, with the help of table 4.1, find out the mass number of oxygen and sulfur atoms. So mass number of oxygen is equal to number of protons plus number of neutrons. Then mass number of oxygen is 8 plus 8, 16. And the mass number of sulfur, number of protons plus number of neutrons, 16 plus 16 is equal to 32. Okay. Next question is, for this symbol HD, tabulate 3 subatomic particles found each of them. So in symbol H, protons is 1, neutron is 0 and electron is 1. And symbol D, proton is 1, neutron is 1 and electron is 1. So there is an important thing that you should remember. In any atom, the number of electrons is always equal to the number of protons. Okay. And the atomic number of any atom is always equal to the number of protons. So the number of protons, atomic number and electrons are always equal. Let's move on to another question. Write the electronic configuration of any pair of isotopes and isobars. Two isotopes of carbons are 12 6 carbon and 14 6 carbon. The electronic configuration of 12 6 carbon is 2 and 4. The electronic configuration of second isobars is 2 and isotope is 2 and 4. Isotopes have same electronic configuration. Okay, and 4029 calcium and 1418 argon as a pair of isobars. The electronic configuration of calcium is 2882. The electronic configuration of argon is 288. Isobars have different electronic configuration. Okay. Next question is, compare the properties of electrons, protons and neutrons. And the answer is, electrons are present outside the nucleus of an atom, protons are present in the nucleus of an atom, neutrons are present in the nucleus of an atom. So proton and neutron are present in the nucleus of an atom, and electrons are present outside the nucleus of an atom. Second difference is, electron are negatively charged, proton are positively charged, and neutron are neutral. Third difference is, the mass of an electron is considered to negligible. The mass of a proton is approximately 2000 times as mass of the electron, and the mass of the neutron is nearly equal to the mass of a proton. What are the limitations? Next question is, what are the limitations of J.J. Thomson's model of an atom? According to J.J. Thomson's model of an atom consists of a positively charged sphere with electrons embedded in it. However, it was later found that the positively charged particles resides at the center of the atom, called the nucleus, and the electrons revolve around the nucleus. So, these were the limitation of J.J. Thomson's model of an atom. Next question is, what are the limitations of the Rutherford's model of the atom? According to Rutherford's model of an atom, electrons revolve around the nucleus in fixed orbits, but an electron revolving in circular orbit will not be stable because during revolution it will experience acceleration. Due to acceleration, the electrons will lose energy in the form of radiations and fall into the nucleus. In such a case, the atom would be highly unstable and collapse. Next question is, describe Bohr's model of the atom. The answer is, Bohr's model of the atom. Niels Bohr proposed the following postulates regarding the model of an atom. Only certain orbits known as discrete orbits of electron are allowed inside the atom. And second is, while revolving in these discrete orbits, the electrons do not radiate energy. These discrete orbits or shell are known as the following, are shown in the following diagrams. So this is K shell, this is L shell, this is M shell, and this is N shell, right? And the center, in the center there is nucleus. The first orbit, that is for number 1, is represented by letter K. Similarly, for number 2 is L and M and N and so on, right? These orbits or shells are also called energy levels. Next question is, compare all the proposed model of an atom given in this chapter. So in this chapter there are 3 models given. First, Thomson's model. An atom consists, according to Thomson's model of an atom consists of a positively charged sphere with electrons embedded in it. According to Rutherford's model, an atom consists of a positively charged particles concentrated at the center known as nucleus. This size of the nucleus is very small as compared to the size of the atom. The electrons revolve around the nucleus in well-defined orbits. According to Bohr's model, there are only certain orbits known as discrete orbits inside the atom in which electrons revolve around the nucleus. Electrons do not radiate energy while revolving. Next question is, summarize the rules for writing of distribution of electrons in various shells for the first 18 elements. How can we distribute the number of electrons in each shell? So the answer is, The rules for writing of the distribution of electrons in various shells for the first 18 elements are given below. The maximum number of electrons that a shell can accommodate is given by the formula 2n square, right, where n is the orbit number or energy level index. The maximum number of electrons present in an orbit of n is 1, given by 2n square is 2. Similarly, for second orbit, this will be 2n square, 2 into 2 square, that is 8, and third orbit 18, and so on, right? The outermost orbit can be accommodated by a maximum number of electrons 8. We cannot exceed the number of electrons in outermost orbit than 8, right? Shells are filled with electrons in a stepwise manner, that is, the outer shell is not occupied with electrons unless the inner shells are completely filled with electrons. So we will only distribute to the outermost shell or to the outsider's shell after giving the electrons to the inner shells first, right? The seventh question is, define valency by taking examples of silicon and oxygen. The valency of an element is the combining capacity of the element. The valency of an element is determined by the number of valence electrons present in the atom of that element. If the number of valence electrons of the atom of an element is less than or equal to 4, then the valency of that element is equal to the number of valence electrons. For example, the atom of silicon has 4 valence electrons. That means in the outermost shell of the silicon there are 4 valence electrons. So the valency of the electron is 4, right? Thus the valency of silicon is 4. On the other hand, if the number of valence electrons of the atom of an element is greater than 4, then the valency of the atom is obtained by subtracting the number of valence electrons from 8, right? For example, the atom of oxygen has 6 valence electrons. That means in the outermost orbit of the oxygen there are 6 valence electrons. So the valency of oxygen will be 8 minus 6, that is 2. Next question is, explain with examples atomic number, mass number, isotopes and isobars. ठीक है. So what is atomic number? The atomic number of an element is the total number of protons present in the atom of that element. For example, nitrogen has 7 protons in its atom. Thus the atomic number of nitrogen is 7. What is mass number? The mass number of an element is the sum of the number of protons and neutrons present in the atom of that element. For example, the atom of boron has 5 protons and 6 neutrons, so that the mass number of boron is 11. What is isotopes? They are atoms of the same element, right? The atoms of the same elements and have same atomic number but different mass numbers or atomic mass. For example, carbon 12 6 and carbon 14 6. So in these two carbons they have same atomic number but different masses. What are isobars? So these are also atoms of different elements having same mass number but different atomic number. So isotopes is just reverse of isobars are just reverse of isotopes. In isotopes there are same atomic number but different masses, but in isobars there are same masses but different atomic numbers. For example, calcium atomic number 20 and argon atomic number 18. The number of electrons in these atoms is different, but the mass number of both that element is 40. That is the total number of neutrons in the atoms of this pair of elements. Two uses of isotopes are as follows. An isotope of uranium is used as a fuel in nuclear reactors. An isotope of cobalt is used in the treatment of cancer. Our next question is, sodium has completely filled K and L shells. Explain. Sodium has atomic number 11, so its electronic configuration 281. When it gives away its outmost shell single electron, it charges to Na plus 10, 2 and 8. The above configuration indicates completely filled Kl shells. Next question is, if bromine atom is available in the form of say 2 isotopes, right? Calculate the average atomic mass of the bromine atom. And the answer is, the average atomic mass of bromine is equal to 79 into 49.7 plus 81 into 50.3 upon 100, that is 80 unit. Next question is, the average atomic mass of a sample of an element X is 16.2 unit. What are the percentage of isotopes in the samples? Since average atomic mass is 16 x plus 18 into 100 minus x upon 100, so after this calculation we will get 90, when 90% of the x16 sample so far x18 sample percent is equal to 100 minus 90, that is 10%. Next question is, if Z is equal to 3, what would be the valency of the element? Also name the element. By Z is equal to 3, we mean that the atomic number of the element is 3, its electronic configuration will be 2 and 1. Hence, the valency of the element is 1. Since the outermost shell has only 1 electron, therefore the element with Z is equal to 3 is lithium. Next question is, composition of the nuclei of two atomic species X and Y are given as under. Proton in X there are 6 protons and 6 neutrons. In Y 6 protons and 8 neutrons. Give the mass number of X and Y. What is the relation between the two species? Mass number of X, number of protons plus number of neutrons 12, and mass number of Y is equal to 14. These two atomic species X and Y have the same atomic number but different mass number. That means they are isotopes. Okay. Next question is, for the following statements write T for true and F for false. So first statement is, J.J. Thomson proposed that the nucleus of an atom contains only nucleus, and this is false. A neutron is, second statement is, a neutron is formed by an electron and a proton combining together, therefore it is neutral. This is also false. Third statement is, the mass of an electron is about 1 upon 2000 times of that of proton, and this is true. And fourth statement is, an isotope of iodine is used for making tincture iodine, which is used as a medicine, and this is true. Next question is, put tick right against correct choice and cross against wrong choice in the following question. Following questions. Rutherford's alpha particle scattering experiment was responsible for the discovery of what? So Rutherford's alpha particle scattering experiment was responsible for the discovery of atomic nucleus. Yes. Electrons no, proton no, neutron no. Next question is, put tick right against correct choice and wrong cross against wrong choice, right? And the question is, isotopes of an element have the same physical properties, different chemical properties, different number of neutrons, different atomic numbers. So the isotopes have same atomic numbers and different masses. And the answer is, isotopes of an element have the same physical properties, wrong, different chemical properties, wrong, different number of neutrons, exactly, right, different atomic numbers. No, they have same atomic numbers. Next question is, number of valence electrons in chlorine ion are 16, no, 8, yes. So the number of electrons in chlorine is number of valence in chlorine is 8. Which one of the following is a correct electronic configuration of sodium? The correct electron configuration of sodium is 2, 8 and 1. Option D is right. Option D is right. Let's move on to another question. Complete the following table. You have to complete this: atomic number, mass number, number of neutrons, number of protons, number of electrons, and name of the atomic species. So in first column, atomic number 9, mass number 19, number of neutrons 10. So when atomic number is 9, that means number of electrons will also be 9 and number of protons will also be 9, right? So when we have number of electrons, number of protons and atomic number, and also we have nothing. So number of neutrons will be 10, and the name of a species is fluorine. So just look at this table and then look at this table, you'll get your answer, right? Let's move on to another question. So that's all from the chapter 4, that is structure of the atom. Thank you very much for watching this video. If you want to note it down in your notebook, so you can pause this video and you can write it into your notebooks. So thank you very much for watching this video. We'll be back after some time with another chapter, with another subject. Till stay tuned with NCERT Zone, and do not forget to subscribe to the channel. Thank you.